This video looks at sections probability B5 to B8. Firstly, let's start with events. Now, a collection of desired outcomes is called an event. The probability in event E is often written as P bracket E bracket. So if I was looking at tossing a single, I might look at the probability of rolling a 1, which would be 1 in 6. The complement of an event includes the outcomes of the sample space that are not the event, or every other possible outcome other than the event itself. So if an event is E, the complement is often written as E dash, or E with a line across it, probably lean towards the E dash. So if we were looking at the probability of not having a 1, if I rolled a dice, there'd be 506 possible options. So 2, 3, 4, 5, 6. So if I had toss a head on a coin, the complement would be toss a tail on a coin. If I had roll an even number on a die, the complement would be roll an odd number on a die. If I had draw an ace from a deck of cards, it'd be not draw an ace. Now let's look at compound probabilities. Compound probabilities result from considering several processes together. Different processes may occur at the same time, or the same process may be repeated more than once. Examples from probability B2 to B4 demonstrate situations involving compound probabilities. Now, mutually exclusive events. Mutually exclusive events cannot occur at the same time. If one event happens, then the other event cannot, or vice versa. It is impossible for both events to happen at the same time. In fact, one event occurring excludes the possibility of another event occurring. So if we look at some examples, it rained on Tuesday and it didn't rain on Tuesday. You can't have both of those happening. It either rained or it didn't. Rolling a 2 and rolling a 5 or a 6 with a 6-sided die. Okay, you can't have those things both happening at the same time. In contrast, examples of non-mutually exclusive events are drawing a king and drawing a heart from a pack of cards. You could draw the king of hearts. Rolling a 2 and an even number. Again, 2 is an even number. So they're non-mutually exclusive. Independent events. Independent events are events such that the outcome of one event has no effect on the outcome of the other. If when selecting more than one object there is replacement of the object prior to a second selection, then the events must be independent. In a physical sense, for independent events, the occurrence of one event does not in any way affect the occurrence of the other event. So some examples of independent events. It was sunny on Friday and my sister is a brunette. They don't affect each other at all. It could be sunny on Friday and my sister will still be a brunette. The weather doesn't affect that. Rolling a 2 on a die and tossing a tail on a coin. Again, they're independent events. Rolling that die does not affect the coin. Examples are non-independent, or another way of putting it, dependent events are drawing a card from a pack of cards and then without replacing the card drawing another card. So if I drew a 2 of hearts from the deck, I can't draw that card again because I've already drawn it. Selecting a person from the women in a company is also a non-independent or dependent event. So language of probability. If there are two equally likely outcomes, A and B, it can be said that there is a 50% of chance of A, there's a 1 in 2 chance of A. A has a 50-50 chance. The odds of A are 1 to 1. A is an even money bet. The probability of A is 0.5, or P bracket A bracket equals a half. So there's all the different ways of saying it. Now note, they were two equally likely outcomes. Now note, you've probably already picked up this. Dice is a plural of die, so 1 die, 2 dice. And there are card facts outlined in Appendix C of the textbook. So if you don't know how many different cards there are and all those kind of things, you might want to brush up on that. Exercise, probability B2.